All right, good afternoon, everyone, and thank you to the Interplanetary Initiative for having me here today to speak with you all and ask this big question. How can lessons from the past, help inform space futures? Now, it may seem maybe a little strange or counterintuitive to have a historian in the room today. It doesn't get more future-focused than the idea of humans living on other planets. Conversations about space technology typically prioritize the new, the next big thing, the as yet unrealized possibilities that may come to fruition on some future day. Of course, the noteworthy successes of decades past motivate current efforts. Innovation and ingenuity and the shared efforts of thousands of people united towards achieving a common goal have yielded the first satellites, humans living and working in orbit, and boot prints on the moon. And these are certainly worth celebrating. Big accomplishments and big failures alike tend to dominate popular memory of the past 60-plus years since the first satellites reached orbit. And we can, of course, learn important lessons from those milestones. Perhaps because of the future-focused character of space discourse, decision makers may opt to approach a problem or a conflict as new or unprecedented. What I'd like to suggest today is the utility and, frankly, the necessity of looking more closely at the smaller moments of success, failure, conflict, and consensus that played a crucial role in shaping spaceflight practices, norms, and space culture broadly writ. So this image that I'm showing you here is the first photograph that Neil Armstrong took during his first spacewalk. And I wanted to show it here because it prominently features what amounts to a space garbage bag full of items that the astronauts no longer needed or wanted. And they're eclipsed in historical memory by the boot prints nearby. But the bag's presence suggests some telling things. Even seemingly mundane earthly practices can and have been easily replicated in other worlds. So looking closely at these smaller and even forgotten parts of history can be deeply informative. Engaging with what has worked, what hasn't worked, and who has had a say in shaping space industry practices in the past can perhaps help forego the need to reinvent the wheel, or maybe more appropriately, the rocket engine. I'd like to provide examples drawn from my ongoing research on the environmental history of outer space to illustrate this. So I first fell down the space junk rabbit hole shortly after the first accidental on-orbit collision between two large objects in orbit. And in the aftermath of that event, I noticed a common refrain repeated in space policy circles, that orbital debris was a relatively new problem, caused by ignorance at best, negligence at worst, on behalf of the United States and the Soviet Union space programs during the 1960s and 1970s. And I quickly learned there was much, much more to this story. Turns out not only had the space industries of the Cold Warring superpowers been aware of the potential dangers of orbital debris early on, but communities around the world understood that outer space was a place that could be polluted, and they understood that from the very start of the space age. More than that, addressing the risks explicitly associated with the byproducts of the space industry brought people who were not space decision makers into conversations about how best to manage a global natural resource that maybe wasn't as infinite as it seemed. So for example, well before the first space telescopes revolutionized methods of studying the cosmos, astronomers engaged in a battle to protect their view of the universe. In the early 1960s, they responded to news of an experimental satellite system for communications called Project Westford. Westford consisted in aggregate of hundreds of millions of tiny copper fibers, which you can see here on this unidentified finger for scale, diffused into a signal-reflecting ring some 3,500 kilometers above the Earth's surface. Military specialists saw these dipoles as valuable communications infrastructure. Optical and radio astronomers saw them as a potential existential threat. Should each nation with a space industry launch their own dense copper belts into orbit, astronomers worried that both ground observations and future space telescopes could be impeded by artificial noise, perhaps permanently. Journalists and concerned letter writers around the world picked up on this controversy and amplified it. They amplified astronomers' protests, and designers of the publicly funded Project Westford heeded astronomers' warnings and made changes between the first and second attempts to launch the test version of the program. Most astronomers were satisfied. The test system yielded no adverse effects, and most of the dipoles fell back to Earth harmlessly within just a few short years. So given the similarities between this historical episode and the recent ongoing controversy over the private satellite megaconstellation Starlink, for example, it's not hard to imagine that examining the contours of this earlier conflict might yield lessons for how to bring more voices to the table to build a stronger consensus on current and future best practices. In the decades that followed the ascent of those westward dipoles, space industry first-comers launched more and more objects into space. And representatives of nations with emerging space programs or with no space programs at all began to raise concerns in international forums about the first-come, first-serve occupation of Earth orbit. Should this mentality persist, they argued, over time, orbital regimes like the valuable and limited geostationary band could eventually no longer be available for use by those outside of the United States, the Soviet Union, and Europe, which had also incidentally played an outsized role in drafting the Outer Space Treaty, which designates outer space as the province of all mankind. As the space age progressed into its second decade, citizens and leaders of nations in the global south protested what they characterized as a kind of neo-colonial resource grab, thousands of kilometers overhead. If space truly belongs to everyone, why should only a few powerful, wealthy early-comers have unmatched access? Historical resistance to space governance models that were egalitarian in word but not in deed showed that extractive practices can persist and replicate colonial power hierarchies, even in a place devoid of humans, biota, or even land. Debates over the ethics of colonization of places like the Moon and Mars continue in our current moment. The cumulative launch tempo has increased to a rate unimaginable in the 60s and 70s, with the number of trackable objects in outer space spiking exponentially, even with just the last 5 years. The power landscape has shifted, with China and India exerting greater influence. As we just mentioned, right, India just accomplished its first lunar landing this week. And private companies, helmed by wealthy individuals, making decisions that would previously have been subjected to greater bureaucratic oversight, for better or for worse. So as this gilded space age accelerates, it's increasingly important to identify and reflect on relevant rhymes with the past. So I'd like to wrap up now with a challenge that may seem a little semantic, but bear with me. I'd like to challenge all of us here to think about a very small but very important word, which is we. In conversations about interplanetary futures, this word comes up often, which makes sense. You don't get to outer space on your own. We will go to the Moon again. We will build habitats on Mars. We will tackle the space debris crisis. We signifies a unified, homogeneous human experience. It implies also an unanimous approach to inhabiting other worlds. But historically, not all of humanity has easily or equally participated in otherworldly endeavors of the space age. So by drawing on a longer, more global view of humanity's place in space, including the forgotten and even messier moments, the we might encompass more voices, more knowledge, more expertise, more equitable approaches to building interplanetary futures, not just for those with the power to immediately dictate those futures, but truly for all of humankind. Thank you.